Welcome everyone. This is Mr. Genesis again with vectors in three dimensions. Welcome to the second part of the study of vectors in three dimensions for high school students. Remember, we are following the Cameroon Advanced Level GCE syllabus as we study through vectors. Now, last time we had already started with the study of vectors. Now we are just continuing. However, we must remind ourselves what we've been doing. In part 1, we studied everything that has to do with in the introduction, that's understanding vectors. We did everything that has to do with this first part, understanding vectors in 2D, working with vectors. Today we are going to be talking on the second part, working with vectors in 3D and lines in 3D. These are the two things which we are going to see this time around. We are going to do our best to make it as snappy as possible as we delve into the study of vectors. Now, working with vectors in 3D from 2D to 3D. We are trying to understand how we change, how we move from 3D to 2D to 3D. So I would say consider the figures below to better understand the concept of 2D and 3D vectors as we move from 2D vectors to 3D vectors. Here we see two diagrams here. You have the x coordinate this way and the y coordinate, and here you have the x, you have the y, and you have the z. Now we look at these two figures. Here you have a square or rectangle. You discover that you can either go either forwards or backwards, or you go up or down. One of these forms of movement. They are restricted. So 2 dimensions means you have the x and the y. Now in 3 dimensions, you can go up, of course, and down. You can go left and right. And now there's one special thing, you can move in and out. So you have up, down, in, out. Up, down, left, right, in, out. So you have 3 different paths you can take. And that in-out path is what we call the z. So you have the x, the y, the z. Now, it's not a law actually. In some notations, in some textbooks, you have x, y, z this way. So it all depends on what you're following. But for now, we are following x, y, and z. We maintain our x and y axis like we've been doing. And then now we just add the z axis for the in and out form of movement. So a square is 2-dimensional and hence has only length and width. Whilst now automatically, given that a square is 2-dimensional and hence has only length and width, so you have OA equals xi plus yj, as we've been saying, as we saw in part 1. And then you have a cube, on the other hand, is 3-dimensional and hence has length, the y, width, the x, and depth. So you have the length, width, and depth, which means there's something new that has been added to the system. We have an example of a vector in such a situation. We have the vector OA to be xi plus yj plus zk. So now we have the I, the j, and the z. I, j, and k rather. Now, if we try to move forward, so working with vectors in 3D from 2D to 3D, remark, a 2D vector is a vector that lacks the z component. Now, a vector that lacks the z component is a 2D vector. A vector that has the z component, now, therefore, it's a 3D vector. We say it's important to know that x corresponds to I, y corresponds to j, and z corresponds to k. So, for example, a 2-dimensional vector, 2i plus 4j, is actually a 2i plus 4j plus 0k, which means the depth part of the vector is absent. Most concepts and workings do not change when we move from 2D to 3D. However, cross product becomes possible. Now, I remember in part 1, we talked about cross product. We talked about multiplication of vectors. And under the multiplication of vectors, we said we have the multiplication by a scale factor. We had multiplication between two or more vectors. Now, multiplication between two or more vectors, we had dot product or scalar product, and then we had cross product. The cross product was not possible with two-dimensional vectors, but it is possible with three-dimensional vectors, because dot product leads to a scalar, but cross product leads to a vector. Cross product multiplies two vectors to keep them as vectors. Now, there are many other reasons for this, but we are going to get there in due time. So we say cross product becomes possible. Direction of the vector does not exist per se. It can only be calculated when one of the components is neglected or considered to be zero. Now, you can calculate the direction of the vector with respect to the x-axis, or calculate the direction of the vector with respect to the y-axis, or respect to the z-axis. The direction of vector, when you say what's the direction of the vector, it becomes a little too vague for it to be calculated. But however, with 2D vectors, it was very simple and very possible. I think now we are getting to examples. Given OA equals 2i minus 3j plus 4k, OB equals 3i plus 2j minus 3k, OC equals 3i plus k, OD equals j plus k. Find. These are our examples and exercises for us to solve. I'm going to go through a good number of them. Well, depending on our time, I don't want to take a lot of time. Depending on our time, I'm going to do a good number of them, and then we'll do the rest as an exercise. Alright. So we are now on our solution slide. If you want to copy the questions, of course, you can pause the video, copy out the questions, and then as we solve, we might also want to solve some of them before we do. So we could still just pause the video and then you solve. But I want to remind you, please subscribe, so that when more videos are uploaded, you will be notified. Also, we noticed that a lot of people who watch this video, who watch our videos, do not like the videos. I don't know if you don't like the video, then I don't think you are going to come back. But we discovered that many of you come back to watch other videos. So do hit the like button as well after subscribing. Thank you. Now, given OA equals that, and OB and OC and OG, find OA plus OC. So we are looking for OA plus OC. We've been given them clearly. So OA plus OC, of course, OA can be written as 2, negative 3, 4 plus OC. OC will be 3. The J component is absent, which means it is 0. Then you have the K component. K component is 1. So this will give us 2 plus 3, 5. Negative 3 plus 0, negative 3. 4 plus 1, 5. So in reality, OA plus OC is going to be 5i minus 3j plus 5k. That is for questions A. Questions B. Questions B, we have 2OB minus 3OA. Of course, this will be 2 into OB. OB we get 3i plus 2j minus 3k. So 3i plus 2j minus 3k. We have minus 3 into OA. OA is 2i minus 3j plus 4k. This gives us, we multiply 2 times 3, we get 6. 4, 2 times negative 3 is negative 6. Minus, we have 3 times 2, 6. Negative 3, rather 3 times negative 3, we get negative 9. And then 3 times 4, we get 12. So this actually gives us 6 minus 6 is 0, so there's no I. 4 minus negative 9, that's 4 plus 9, that's 13j. And we have negative 6 minus 12, that's minus 18k. Move on to this third one, question C. We have OC dot OD. Now OC dot OG, OC is 3I plus K dot OG. Yes, OG is J plus K, of course. Now to do this in a snappy way, of course, you will have 3I no J plus K dot no I plus J plus K. So you notice that for the D I have added the I, and here I added the J. It's simply to make my work easy, not to make confusion or not. You notice that I have added my I, 0I and the 0J. This is in order to reduce the possibility of error. So we are going to end up with 3 times 0, which is 0. Let's do it so gently. We end up with 3 times 0 plus 0 times 1 plus 1 times 1. This gives us 0 plus 0 plus 1. So we have 1. Questions D. We have magnitude of OA. Of course, magnitude of OA, we are going to end up with 2 squared plus negative 3 squared plus 4 squared. This will give us square root of 4 plus 9 plus 16. This gives us 4 plus this is 25, that's 29, that's root 29. Yeah, that makes sense. Now 29 is the same as 9. Yeah, let's keep it like that. So we have now magnitude of OB. Magnitude of OB will have square root of 3 squared plus 2 squared minus 3, that's plus negative 3 squared. This will give us 9 plus 4 plus 9. So we have 18, 19, 20, 22, root 22. Can we simplify 22? 22 is 11 times 2. Well, it doesn't have any square number in it, but we can multiply it. So that is our answer. I'm going to leave you to do magnitude of OC. You're going to do that by yourself. Now we have OA dot OB again. You're still going to do that by yourself. That will still be an assignment. So you have this as an exercise. You have this as exercise. Now the cosine of the angle between OA and OB. An interesting one. We have questions F. You're looking for the angle between OA and OB. Of course, we said that if we have two vectors A and B, A dot B should be equal to magnitude of A, magnitude of B, cos theta, which means cos theta should be equal to A dot B divided by magnitude of A, magnitude of B. If this is true, then we can say cos theta in this case should be OA dot OB, all of that on magnitude of OA, magnitude of OB. Now, do we have OA dot OB? OA dot OB, we haven't done that. We didn't do it. It's question E. So in the end, I'm gonna do it for you. So OA dot OB, OA dot OB, OA, we are going to have 2 times 3. So 2 times 3, that gives us 6 plus negative 3 times 2, that still gives us 6. So that's negative 6. Then we have 4 times negative 3, that gives us negative 12. All of that on Magnitude of OA, we found magnitude of OA somewhere here. Yes, magnitude of OB, we got root 29 times magnitude of OB, we got root 22. Permit me to continue this way. So we get cos theta to be equal to negative 12 divided by the square root of 29 times 22. I'm sure we remember our laws of surds. Sorry about that. We get negative 12 divided by the square root of 29 times 22. It gives us root 638. If I punch my calculator correctly, I'm going to end up with negative 0.48. That is cos theta. The question says we should find the cosine of the angle between them. So the cosine of the angle, cos theta, is equal to negative 0.48. That is the solution there. We're going to find the angle itself. Now, questions G. For us to do questions G, we are going to go to the next slide. We are out of space here. Now, on our new slide, questions G, we are to find AB. The vector AB is equal to the vector OB minus OA. That gives us OB 3, 2, negative 3 minus OA. OA is 2, negative 3, 4. So this will give us 3 minus 2, that's 1. So we have I, 2 minus negative 3, that's 2 plus 3, 5. So we have plus 5J, negative 3 minus 4. Negative 3 minus 4, we get negative 7. So minus 7K. And that's 80. You are going to do for BC and CD. It's going to be the same thing. OC minus OB, OD minus OC. I've practically done it for you. Now H says the angle between OC and OD. Angle between OC and OD. Let's do it here. H. Now we are well aware that cos theta should be equal to OC dot OD divided by magnitude of OC, magnitude of OD. Of course, you can start taking your formula from here. So we need to do OC dot OD. OC dot OD, we go ahead. Here is OC, here is OD. Okay, so that I can do it snappy. We have I minus 0. Okay, let's just write it down before we get more confused. So we have 3I, no J, no J, plus K, and then we have dot, no I, plus J, plus K. Yeah, now I remember we have done this already. We've done this already. And magnitude of OC will be 3 squared plus 1 squared times magnitude of OD will be 1 squared plus 1 squared. This will give us 1 on this is 9 plus 1, so we get root 10 times root 2. Practically this is root 20, so we get 1 on root 20. Root 20 is the same as 20 times 4, so that gives us 20 is the same as rather 5 times 4, so we end up with 2 root 5. Now we are looking for the angle here, not the cosine of the angle, which means theta will be equal to cos inverse of 1 on 2 equal to 5. This will give us an angle of 77.08 degrees if we punch our calculators properly. Now, let's move on straight away, save time. Questions I. Here we are going to do cross product. It's sad that I prepared just one question on cross product, but in due time we are going to do a lot more. Especially when we are going to be answering a past Cameroon GCE questions. We are going to find some of them there, of course. So just like I said, subscribe and make sure you click the notification bell so that each time you upload a new video, you will be notified. And if you have watched us till this point, please do us a favor and click the like button as well. Thank you. So OA cross OB. Now this is how we're going to do it. First, I'm going to write OA again. Yes. So we have 2i minus 3j plus 4k cross 3i plus 2j minus 3k. Now when doing cross product, the first thing is to maintain the components. So I have I, j, k. Now my OA, I write it first. My OA, I'll write it first. My OA is 2, negative 3, 4. And then now my OB is 3, 2, negative 3. Another question you have in your mind, what if you interchange it? You are going to have a different answer, because OA cross OB is not the same as OB cross OA. They are not the same. Now, in principle, cross product is like taking the determinant of this guy. If you've not done matrices, 3 by 3 matrices, determinant of 3 by 3 matrices, this is it already that we are looking at. Now, although we will not explain here in detail, of course, unless in the video concerning matrices, we won't be done here so detailedly. So we keep I. Now these sections, for those for us who have not done matrices, these sections have what we call cofactor signs. Now I will attribute cofactor signs here: positive, negative, and positive. These are cofactor signs. Now you could put negative and positive, negative, but that's in matrices. It's preferable, like as we are here, it's positive, negative, positive. So you end up with I. We are multiplying. Now when we take I, we short all of these sections, so we no longer consider these. We work only with these. So if you short everything that is linked to I, that's vertically and horizontally, you'll be left with 3, that's negative 3, 4, 2, negative 3. So it's actually magnitude. Then you have minus j. You'll be left with, if you short everything that has to do with j, horizontally and vertically, I have 2, 4 left, and then 3, negative 3. Then we have k. This k, short everything that has to do with k, horizontally and vertically, we will be left with 2, negative 3, and 3, 2. Now, determinant of a 2 by 2 matrix, of course, is supposed to be child's play for us at the advanced level, given that we have fun with it a lot in the ordinary level. So negative 3 times negative 3 is 9, 9 minus. So we get 9 minus 8 minus j into, here we get negative 6 minus 4 times 3, 12, plus k into, we have 4 minus negative 9. So our answer, our cross product is 9 minus 8, that's 1. 1 times I, we have I. Negative 6 minus 12, we have minus 18j. And finally, 4 plus 9, that's 13k. That is our cross product. Of course, more examples will be coming. If you still want to have a grasp, you can pause the video, go through it, or even rewind and then You see, double tap maybe once or twice, depending on the number of seconds that you used to do that, and then you rewatch it to get to know what we are talking about. So the previous exercises were meant just to show us how we can move from 2D to 3D. Now this is a special assignment which I want you to try out before we go to the next one. So we have relative to an origin O, the position vectors of points A and B are 2i plus j plus 2k and 3i minus 2j plus pk respectively. So I want you to take this assignment. You could pause the video, copy it out, and do it. Now I say this assignment actually will be answered in a different video and attached in the description. So when we are going to solve it on a different video, we'll attach the link to that video in the description. With the link to that video, yes, in this description of this video, and then we'll attach this video also to the description of that video so that you could easily put 2 and 2 together. So we're going to solve this. That's why I said you should subscribe, so that each time we upload, you will know what we've uploaded, and then so that when the correction of this assignment will come up, you will see it. This question was taken from Cambridge AS and A-Level Mathematics 9709, paper 1, questions 10, 2008. So it's on Cambridge AS and A-Level examination question. Okay, equation of a line. So we are working now in 3D, lines in 3D, our second segment of our lesson for today. So consider the adjacent figure presenting a line OA in a 3D plane with the coordinates of A being 4, 3, negative 4 in vector form. The coordinates of A are 4i plus 3j minus 4k. Now, when you look at this figure, this is the figure we are talking about, of course. When you look at this figure, you notice that we have a base here in different color, something orange. So when you look at this, it looks like it has divided the paper into a down section and an upper section. Actually, you notice that it is on the x section. It's cutting round the x-axis. Now, at the same time, you have another segment which should be greenish, but it's light green. So what does it do? It separates now into a front and back of the screen. It can somehow make the screen look not two-dimensional. Our screen looks two-dimensional. This slide is two-dimensional, but based on the diagram, it has made it in such a way that you can see that there is a front and a back to your screen. That's what that diagram has done. And now, so the point A that we are reading here can no longer be read as we used to traditionally read. So we have to find the x value of this point, the y value, and the z value. That's what gave us 4, 3, negative 4. You follow this perpendicularly, it goes down to negative 4 and goes to 4 on the x. So this is negative 4 on the z, and this is 4 on the x. And then you also have a 3 on the y. Take note that all of these angles are perpendicular. All of them are perpendicular because the x and the y and the z axis are all perpendicular to each other. The y is perpendicular to the z is perpendicular to the x is perpendicular to the y, and the x perpendicular to the z. So they are all perpendicular to each other. Okay. Now, because the vector OA starts from the origin, it is called a position vector. Yeah, our vector starts from here, moving up to this side. So it's a position vector. To write the equation of a line, we need a direction vector that plays the same function as the gradient of the line in coordinate geometry. In coordinate geometry, we usually write lines in this form: y equals mx plus c, where m is the gradient. Now, this gradient, the direction vector that we are talking about, in vectors plays the same function as this gradient. It tells us how. Take note that the gradient in coordinate geometry, we said the gradient is the same as tan theta, and tan theta of course is the direction, the slope, how bent, that's what the gradient is, how, to what degree is the line bent, what is the slope. That's actually another term for gradient, the slope of the line. Now, and that's exactly what the direction vector plays. That's that function the direction vector plays. In 3D, let's study the equation of a line in two ways. We have one, the vector equation of a line. Now, the vector equation of a line joining 2 points on the Cartesian plane can be written as r equals a plus lambda b, where a can be any of the 2 points and lambda is a real constant, and b is the direction vector of both vector points gotten by subtracting one vector from the other. Of course, the direction vector of OA, if we have OA and OB, their direction vector will be AB, and AB is OB minus OA. That's what we are saying here, gotten by subtracting one vector from the other. Now, if we are writing the equation of a line passing through OA and OB, OA can be here in the place of A bar, A, and OB can be in the place of A. But one thing is sure, that in the place of B, you must have the direction vector. Now, lambda is any constant. That's why you can put either OA or OB. Because if you put OA, lambda will have a different value from when you put OB. However, the equation of the line remains the same. It remains useful and valuable. Examples and exercises. So we write the vector equation of the line passing through the points or vectors these. So we need the equation of the line passing through these points. Let's just move on. Smooth. Without wasting a lot of time, write the vector equation of the lines passing through these. So we have 5 systems. I'm going to do 2, of course. I'm going to do just 2. We do the other 3 because it's really exactly the same thing all the time. So for the first one, number 1, we have 2 points, and we can transform those points into vectors. So we are going to say OA will be 3i plus 2j plus k, and OB will be negative 2i plus j plus 4k. Now, if this is what we have, of course, our direction vector will be AB. Our direction vector will be AB, which will be OB minus OA. OB minus OA, we are going to have negative 2, 1, 4 minus 3, 2, 1. So that gives us negative 2 minus 3. We have negative 5i, 1 minus 2, negative 1. So we have negative j. 4 minus 1, 3. So we have 3k. That's our direction vector. Therefore, the line, we'll call it L1, will be such that r is equal to, we are going to say OA plus lambda AB. This will give us 3i plus 2j plus k plus lambda AB is negative 5i minus j plus 3k, and that's our answer. Or, given that the question did not precise which of them we should give, so we can still write, or if you wrote negative 2i, let's make it this way. If you wrote OB plus, I'm going to use beta now. Since I've already used lambda here, I will use beta now this way. This will give OB, our OB is negative 2i plus j plus 4k plus beta into negative 5i minus j plus 3k. These two equations are correct. They might look different, but they are correct. Why? Because we know the line passes through either the point A or the point B, and the direction vector is the same. So it is the same line. The gradient is okay, and we have used one of the points that the line is passing through. So which means the line is correct. As simple as that. Now, numbers 2, we have 4i. We are going to select, since we're not given any points, we're not given any levels. So select OA, B, 4i plus 3j minus 4k, and OB, B, I plus 3j minus 2k. What we are going to do, of course, we find our direction vector, which is AB. Our direction vector AB will be OB minus OA. This will give us OB 1, 3, negative 2. Please be reminded that you can also ask any question you have as far as it concerns what we are doing here in the comment section. 1 minus 4, that's negative 3i, 3 minus 3, 0, 2, negative 2 plus 4, that will give us plus 2k. Take note, you can ask us any question as far as it concerns what we are doing here in the comment section, and be sure you will get a response from us. So we get therefore, I'll call this now line 2, is such that r will be equal to, I will use OA plus, let's use mu this time. You can use like any variable symbol you want, but preferably we use Greek symbols. So OA plus mu into AB. That gives us OA 4i plus 3j minus 4k plus mu into our AB was negative 3i plus 2k, or you use r equals OB plus alpha into AB. Like I said, we preferably use Greek letters. So OB, our OB is I plus 3j minus 2k plus alpha into negative 3i plus 2k, and that's our answer. So we are going to do the third, the fourth, and the fifth as an exercise or assignment. Post the answers here in the comment section, and when you're done, and of course they are going to give you a thumbs up for a try, and of course we'll notify you if they are correct or not. If there's any correction that we notice, if we notice it's wrong, we will try to give you a correction, maybe hinting you based on the type of error that you could have made. We will see what we can do to put you on the right track. We have the parametric equation of a line. This is another form of writing lines in 3 dimensions. Even in 2 dimensions, you can write equations in parametric form. Now, in parametric form, it simply means we have what we call a parameter. So the parametric equation of a line makes use of a vector equation of a line. As a matter of fact, they are interchangeable. So you can interchange between vector equation of a line and parametric equation of a line. Now, the constant that we multiply the direction vector with is actually our parameter, the parameter I just spoke about. So this parameter it can change. Okay, now let's just walk through what we have on the screen. Consider a line L where r equals a plus lambda b. Now A is a vector and B is a vector. Now arrow itself, of course, is a vector, as we can see already on the screen. So arrow is a vector. Xi plus yj plus zk is the vector equation of a line. So xi plus yj plus zk. Now A for the vector A here, for the vector A, I used A1, A2, and A3 to be the points on the coordinates, and then for the vector B, I used the B1, B2, B3 to be its coordinates. So it's just A and B. So xi plus yj plus zk should be equals to A1i A2j plus A2 A3k plus lambda. So this is our parameter. Now, what we are going to do, of course, we open the brackets here. To open this bracket in order to have this. So yeah, that everything is the same except for here. We open the brackets, we send the lambda inside. We are trying to express this equation in parametric form. Now, the next thing we do, we bring all the terms in I together and all the terms in J together. So that's why you notice A1I, lambda B1I. So this has migrated. This has also migrated to meet J, and then this has migrated to meet K as well. Let's keep it clean. Now, after migrating, now what we do, we factor out the i's, of course. So this is I and I, so we factor out I, and then we keep A1 plus lambda B1. We have A2 lambda B2, A3 lambda B3, factored out i's here, you factored out kj's, and you factored out k's. Now by comparison, the parametric equation will be, we have x equals A1 plus lambda B1, y equals A1 plus lambda. Oh, there was a slight error here. So we are going to have x to be equals to A1 plus lambda B1, y equals A2 plus lambda B2, and z equals A3 plus lambda B3. Now this is just one of the methods. This is just one of the methods of writing these parametric equations. Now this parametric equation can still be transformed into another form. In some textbooks, you are going to see it this way. So which means from here, they are going to make lambda subject of formula. So from here, if we make lambda subject of formula, lambda will be equal to x minus a on b1. Here, lambda will be equals to y minus a2, yes, a1 on b2, and if we make lambda subject here, lambda will be equals to z minus a3 on b3. Now from here, lambda of course will equals lambda equals lambda, so you will end up with x minus a1 on b1 should be equal to y minus a2 on b2 to be equals to z minus a3 on b3. This is another way of writing the parametric equation of a line. It's another method. So there are two methods. You have this and you have this. These are our questions. Give the parametric equation of a line passing through the origin with direction vector 5, -1, 4. So these are our examples in solution. First one, we have been given the directional vector already. Our directional vector is 5i minus j plus 4k. We are reading the points. 5i minus 1j, so minus j plus 4k. Now, they say give the parametric equation of the line passing through the origin with directional vector that. So it's passing through the origin, and given us one point that is passing through. That point that is passing through the origin. So 0i plus 0j plus 0k. Are you with me? Now, based on this, we know that its vector equation L, let's say 1, will be, the vector equation will be 0i plus 0j plus 0k plus beta, we choose beta, into 5i minus j plus 4k. Now, if this is true, then we know that xi plus yj plus zk should be equal to 5 beta I minus beta j plus 4 beta k, which means x is equals to, or is equal to 5 beta, y is equal to negative beta, and z is equal to 4 beta. If we make beta subject of formula, it will mean beta is equals to x on 5, or beta is equal to negative y, or beta is equal to z on 4, which will imply x on 5 equals negative y equals z on 4. This is our parametric equation of the line. We move on to the second. In second place, write the parametric equation of a straight line L passing through the points this and the midpoint between V1, B and C. So we need the midpoint. So it's passing through this and it's passing through the midpoint of this. Not passing through any of them. It's not passing through B, not passing through C. So we need the midpoint of BC. Midpoint of BC is 1 plus 3 divided by 2. That's 4 on 2. Let's say 1 plus 3 on 2. Negative 1 plus 5 on 2. And finally, 1 plus 5 on 2. That gives us 2, 2, 3. That's the midpoint. So it's passing through the midpoint, and it's also passing through a 3, 3, negative 1. So direction vector. Our direction vector will be AM, which is equals to the M, that's 2, 2, 3 minus 3, 3, negative 1. So we end up with 2 minus 3, that's negative I, 2 minus 3, negative I, 3 minus minus 1, we have 4G. That's our directional vector. Therefore, our line L, let's say L2, L2 will be such that arrow is equal to, yes, arrow is equal to, we'll use, now I would prefer not to use the midpoint here, I will use the point A. So we'll have 3i plus 3j minus k plus mu into negative I minus j, yes, j minus j plus 4k, such that x here will be equal to 3 minus mu, so that mu is equal to, so that mu here will be equal to 3 minus x. Then you also have the y component, y equals 3 minus mu, so that mu is equal to 3 minus y. And then you also have for the z component, that's k, you are going to have -1, usually the coefficients of course, plus 4 mu, which means mu in this case will be z plus 1 on 4. Therefore, your parametric equation will be mu, so this equals this. So 3 minus x should be equal to 3 minus y, which should be equal to z plus 1 on 4. And that is your parametric equation. We advance. Well, I'm going to let you do the third one as an exercise. You do the third one as an exercise. Drop the answer in the comment section and we'll give you a thumbs up. Remember to subscribe. Click the like button if you are with us right up to here. Come on, it doesn't hurt. Intersections between lines. Well, apparently we still had something to do. So intersections between lines, as two or more loci intersect, their coordinates at the points of intersection are equal. This means when lines intersect, all their coordinates x, y, and z are all equal. In the previous example, one of the major objectives was for us to be able to figure out the different coordinates. So we're able to figure out x coordinates, we're able to figure out the y coordinate and the z coordinate. We're able to tell that the x coordinate from here is a combination of this and this. We're able to tell that the y coordinate from here is a combination of this and this. We're able to tell that the z coordinate from here is a combination of this and this. We're able to make that clearly known. So we are going to be applying that knowledge now on this in this section of the study. Now, say the vector equations of two lines are given by L1 equals. These are examples, yes. These are examples and they are Cameron GCE questions. Examples and exercises. The Cameron GCE question. The vector equation of two lines are given by L1 equals that, L2 equals that. You can pause the video and copy the questions. The vector equation of two lines given by L1, they've given us L1 and L2. Now they're telling us to find the position vector of the point of intersection of L1 and L2. B, the cosine of the acute angle between L1 and L2. So let's find the position vector of the intersection first of all. So we have said at the intersection, they are both equal. First of all, solution. So L1 is such that arrow is equal to 13i plus 4j plus 11k plus lambda into 2i plus j plus 3k, and L2 is such that arrow is equal to 5i plus 22j plus 9k plus mu into 7i minus 17j minus 5k. Okay, that's what has been given to us. Now at intersection, L1 is equal to L2. If L1 is equal to L2, then the x coordinates of L1 should be equal to the x coordinates of L2. So all coordinates are equal. So now that will imply 13 from L1 13 plus 2 lambda should be equal to 5 plus 7 mu. I arrange it into a nice and decent equation. So I'm going to end up with 7 mu minus 2 lambda to be equal to 8. I call that equation 1. Also, now I take the j components. For the j components, we have 4 plus lambda should be equal to 22 minus 17 mu. Okay, I arrange it also into a decent equation where I'm going to end up with 17 mu plus lambda to be equal to, so 17 mu, this came this way, plus lambda equals 22 minus 4. That will give us 18. We can call that equation 2. Well, I'm going to stop here, but you could go for the j as well. But let's just go for the j. Also, for the j, 11 plus 3k should be equal to 9 minus 5 mu. Arranging it to a decent equation, we will have 5 mu plus 3k to be equal to negative 2. That's equation 3. So we can solve any pair of these equations, of these 3 equations, to get the correct value for mu and lambda. So we'll end up with, I will use equations 1 and 2. 7 mu minus 2 lambda equals 8. Equations 1. And equations 2. 17 mu plus lambda, yes, equals 18. Equation 2. Going to use something simultaneously. We are going to say equations, since we want to eliminate lambda, we're trying to eliminate lambda, so we'll multiply this by equation 2, by 2 rather. So we'll say equation 1, we'll say equations 1 plus 2 of equations 2. This will give us 7 mu plus 34 mu to be equal to, since this will cancel out, we'll have 8 plus 18 times 2, that is 36. So we end up with 34 plus 6, that's 41 mu to be equal to 36 plus 4 was 40, so we have 44. So mu will be equal to 44 on 41. This will give us approximately 1.07. Approximately 1.07. Now, to find the point of position vector of the point of intersection, once you have found one of the parameters, it's enough. You don't need the other one. So once we have found mu, we can substitute mu in the equation where mu is found in. Mu is in L2. We substitute mu in L2. So R, of course, which is in the form xi plus yj plus zk, as we well know, will become, we will get 5i plus 22j plus 9k plus 1.07 into 7i minus 17j minus 5k. This will leave us with 5i plus 22j plus 9k plus 1.07 times 1.07 times 7 gives us 7.5. So we have plus 7.5i minus 1.07 times 17 gives us 18.24. So we have minus 18.24j. Then we have minus 1.07 times 5 gives us 5.37. So we have minus 5.37k. We now sum them. So 5 plus 7.5, 5 plus 7.5, that's 12.5 I, and then we have 22 minus 18.2, 22 minus 18.2 gives us 3.8. So we have plus 3.8j, and then 9k minus 5.37. So 9 minus 5.37, that gives us 3.63 j. This is the position vector of the point of intersection of these two lines. Now for the B part, this was the A part of the question. For the B part of the question, the cosine of the acute angle between L1 and L2. So cos theta will be equal to the directional vector of 1 dot directional vector of 2 divided by magnitude of directional vector 1 into magnitude of directional vector 2. So technically what we have is going to be 2i plus j plus 3k dot 7i minus 17j minus 5k divided by, we have 2 squared is 4, 1 squared is 1, so we have that plus 1, 3 squared is 9, root 7 squared 49, we have 17 squared or negative 17 squared, that is 17 squared is 289, and then we have negative 5 squared is 5. This gives us 2 times 7 is 14, 1 times 17, so we have minus 17, then we have 3, we have minus 15, that's 3 times 5, yes. So this will give us you have negative 1, divided by, was forgetting our guys under there. Here we have 9, 10, 14 root, there we have 289 plus, we have 289 plus 49 plus 25, that gives us 363. So this will end up in negative 18 on Group 363, I have 19.05, and group 14, 3.74. So the cosine of this angle will be negative 18 divided by 3.74 times 19.05. This will give us negative 18 divided by 71.25. This will give us negative 0.25, and that is our solution. Now, for the sake of time, you are going to do the second one for yourself. For the sake of time, you are going to do the second one for yourself as an assignment. You add it to your assignment, and we are going to work it out. Given that it's a GCE question, of course, we are going to face it in a special video. So, another assignment. So you have lots of assignments, and given that all these assignments are GCE questions, we are going to face them in their own videos concerning this chapter. As all these GCE questions concerning a particular chapter, they will be solved in due time and uploaded as their own videos. So do well to subscribe, click the notification bell so that you can get notified each time a new video will be uploaded. I need not remind you that we are the Alpha Study Group, and we have past GCE questions, past mock questions on our website for you. Thanks for following. I am Mr. Genesis, and I have been your facilitator. Thank you for following.